Hey everyone, and welcome. Today, we're grabbing our magnifying glasses and putting on our detective hats. Why? Because we're about to crack a classic data mystery: how to hunt down duplicate emails in a database.
You know, every data set has a story to tell. But sometimes it's hiding secrets. And duplicate entries, they can really mess things up, skewing your analytics, causing weird bugs, or even leading to some pretty embarrassing oops moments with customers. So the real question is, what's really hiding in your data?
So, here's our mission, should you choose to accept it. We need to write a query that can scan a database table and flag every single email address that shows up more than once. This is one of those fundamental gotta-know skills for anyone working with data, and we're going to solve it together.
All right, let's open up the case file. Here's our evidence, a simple little table called person. It's got just two columns, ID and email. Now, take a close look. You see it, right? The email, a@b.com, is in there twice, tied to IDs 1 and 3. That, my friends, is our target. That's the duplicate our query needs to sniff out.
So how do we catch this culprit? Our first technique is an absolute classic. I like to call it the group up, and it uses two of SQL's most powerful tools, group by and having.
So what's the deal with group by? Well, think of it like sorting your evidence into boxes. It takes all the rows that share a certain property, for us that's the email address, and it bundles them together into little groups. Once they're grouped, we can run functions like count on each of those little bundles.
Our investigative process here is a super straightforward three-step plan. First, we tell the database to group everything by the email address. Step 2, we count how many rows are in each of those brand new groups. And finally, step 3, we just tell it to show us only the groups that have a count higher than 1. Simple as that.
And here's a little peek at what's happening behind the scenes. The database is logically rearranging everything. See how it bundles the two at a.b.com rows together? And poor c@d.com is left all by itself in its own group? The sorting is done. Now for the analysis.
This right here is the key to the whole operation. It's this simple little condition. We only care about groups with a count greater than 1. After all that grouping and counting, this little filter is what lets us completely ignore the unique entries and focus only on the duplicates.
And voila, here is the final query in all its glory. We select the email from the person table, we group by email, and then here's the magic, having count of the email greater than 1. Now this specific count checks for non-null emails. You might also see count of asterisks in the wild, which counts every row in the group. It can sometimes be a tiny bit faster, but for this case, the result is exactly the same. Case closed, for now.
But wait, as any good detective knows, there's always more than one way to crack a case. So let's check out our second method, a clever technique I call the cross-reference, which uses something called a self-join.
A self-join. I know, it sounds a little weird, right? Joining a table to itself, but it's an incredibly powerful way to compare rows within the same table. Just imagine making a photocopy of your evidence list and then going line by line, comparing the original list to the copy. That's basically what a self-join is doing.
So to pull this off, we have to pretend that we have two identical copies of our person table. To keep them straight, we give them nicknames or aliases. We'll call the first copy P1 and the second one P2. This setup allows us to compare every row from P1 against every single row from P2.
Okay, for this to work, there are two rules we absolutely have to follow. First, we're looking for rows where the email in P1 is the same as the email in P2. That's how we find potential duplicates. But second, and this is absolutely crucial, the IDs have to be different. Why? Well, if we didn't add that rule, every single row would just match with itself, which tells us nothing. We only want to find cases where an email matches a different row.
And here's the query that puts that logic into action. We select the email from P1. In the from clause, you can see we list the person table twice, giving it the P1 and P2 aliases. Then our where clause applies those two critical conditions. And notice that distinct keyword? Super important. That's what stops us from getting the same duplicate email listed over and over again in our results.
All right, so we've successfully used two totally different methods to hunt down our duplicate. Now it's time to write up the final report. Let's step back and compare these two approaches.
When you put them side by side like this, you can really see the different philosophies at play. The group by method is all about sorting and summarizing first, then filtering. The self-join, on the other hand, creates this massive combination of every possible row pairing and then filters it all down. So here's the bottom line.
For this specific problem, the group by approach is almost always going to be more efficient and faster, especially when you're working with a really big data set.
And hey, this logic, it's not just locked away in the world of SQL. If you happen to be working in Python with the Pandas library, which is super popular for data analysis, the idea is exactly the same. There's a handy duplicated method that does all the heavy lifting for you. The tools and the syntax might change, but that core concept of find what appears more than once is totally universal.
Okay, so after all that sleuthing, what new tools have we actually added to our detective toolkit? Let's quickly recap the key takeaways from this case. So just remember, group by with that having clause, that's your go-to, your fast, direct, and efficient method for finding simple duplicates. It's what it was built for. The self-join is more like a multi-tool. It's super powerful and flexible, and it really shines when you need to do more complex comparisons, like finding all the employees in a table who report to the same manager.
And just like that, we've cracked the case of the duplicate emails. But finding the problem is really just the first step. The real question is, what are you going to do next? Are you going to delete them, merge them, or maybe you'll investigate why they're happening in the first place to stop them from ever coming back? In the world of data, the investigation is never truly over.